All right, hey guys, lesson 9 today, where we're looking at mean specifically. Now, many of you have been introduced to this through the little rap that I taught you earlier this year. So, hey diddle diddle, the median's the middle. We add then divide for the mean. The mode is the one that appears the most, and the range is the difference between. So that little rhyme that we used when we just kind of dabbled in this in Rocket Time earlier this year is going to give us a very mathematical way to calculate a mean. But to get a better understanding of what exactly mean is or why we would do that, we're going to be looking at mean as fair share. So we're going to look at a more logical way to solve it before we get into a calculated or exact science on it. So I'm going to skip past this part and look at this spread out and share portion. So the kittens in a room at an animal shelter are placed in 5 crates. 1, 2, 3, 4, 5. Here's our 5 crates at the animal shelter. The manager of the shelter wants the kittens distributed equally among the crates. That just seems logical. I don't know why you wouldn't do that. How might that be done? So right now, it's not equally distributed. We've got an empty crate. We've got a crate that's got 4 kitties all jammed together in it, and then this single lonely cat over here. So if we want to equally distribute them, I might take one of these kitties and put him over here. So we end up with a second. Yep, there's my cat. All right, he's beautiful. And then we've got 2, 2, well, if I moved him, 3, 3. Still not equally distributed because we've got more in these 2. And we still have this empty crate down here on the end. So in order to equal this out, well, let's move one of these kitties over here and get it so now there's just 2 cats here. There's 2 like we started out with. There are 2 in here now that we moved one over. This crate still has 3 and this crate only has 1. So I can finish this out by taking one of those 3 kitties that were still in there, moving that kitty cat down here so he's got a buddy. And those kitties can now end up where we've got 2, 2, 2, 2, and 2. So we didn't add or subtract any of the cats. We simply rearranged them so that way they were the same amount. So that way they had enough space and they each had a buddy, and just kind of that idea of a fair share of space there. So the number of kittens in each crate after they are equally distributed is called the mean. So the mean number of kittens per crate, or average number of kittens per crate, here is going to be how many kittens ended up there. Well, we ended up with 2 in each. So in this case, the mean would be 2 kittens, 2 cats. It wants us to explain how the expression 10 divided by 5 relates to this. Well, 10 divided by 5 definitely gives us 2. So yes, the answers match here. But it's more than just the answers matching up. When we look at what actually happened up above and what we started out with, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cats that were on the original drawing, 10 illustrated or printed cats, I guess. So 10 was the number of cats that we had, and 5 then was the number of crates that they were spread out amongst. 1, 2, 3, 4, and 5. So this division problem not only gives us the answer here, but it makes sense with the visual that we've got. So I'm going to repeat that again. Hey diddle diddle, the median's the middle. You add, then divide for the mean. Well, divide. Here's that division part. The adding up part will make more sense as we do more. But we've got this. So the 2 then represents how many cats per crate. So total cats, crates available, cats per crate is what we get when we actually do that division. Another room in the shelter has 6 crates. No 2 crates has the same number of kittens, and there is an average of 3 kittens per crate. Draw or describe at least 2 different arrangements of the kittens that matches this description. So 6 crates. All right, so here's my crates. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, 6 crates. My kittens are just gonna be little round heads here because, well, my artistic abilities are failing me. No 2 crates has the same number. There's an average of 3, so average of 3. 3 is the fair share. 3 is the typical, but no 2 has the same. Draw or describe at least 2 different arrangements. All right, well, let's figure out one arrangement and go from there. So 1, 2, 3. All right. No 2 crates is the same. So I'm going to start and go ahead and leave one of them blank, and that'll be my empty crate. Now this crate, I'm going to have 1. This crate, I'll have 2. This crate, I'll go 3. This crate, I'll go 4. And this crate, I'll go 5. Now, I have 6 crates. None of them has the same number in it. But this idea of an average of 3 kittens, here's where the add then divide for the mean makes more sense. I'm going to add up or count up how many kittens I drew in there altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That gave me 15 kittens. And if I divide 15 by the number of crates that we had, well, that doesn't divide out evenly. 15 divided by 5 would be 3. 15 divided by 6 is going to give us a decimal or a fraction because that's not a basic fact. So if I want to get 3 as my answer, and I know 6 is the number of crates that I'm going to get there, well, what number divided by 6 gives us 3? That's what I need to figure out in order to solve this. So since, sorry, trying to find a different color here, 18 divided by 6 gives us 3, because I know this fact family, I'm going to go back in now and make it so I actually have 18 cats altogether, since I'm going to have an average of 3 kittens per crate. So I had 15, here's 16, 17, and 18. Now, I added them where I did because of this whole idea that no 2 crates has the same. This is tricky. They've given you quite a puzzle here to figure out, but I think we beat their puzzle. So 6 cats, 5, 4, 2, and 1. That works. Draw or describe at least. Okay, I was just making sure it didn't say anything about like no cages being empty or anything, and it doesn't. So this is one arrangement that works. Since it says 2 different arrangements, a separate way that we could do this, since we still need to average 3, that tells me we're still going to be utilizing a total of 18 cats, since 18 split up amongst the 6 cages or divided by 6 gives us 3. That tells me that I need to work with a different way of moving the cats around so they still have no 2 of the same number. I'm not going to draw that out for you, but I do want you to see if you can come up with another way. All right, let's see. We're at about 9 minutes here on our video. And I want to look at one last thing with you. So, let's head over. I think we'll go to the getting to school portion here. And on getting to school, for the past 12 school days, Mai has recorded how long her bus rides to school take. This works well with the last lesson. The times she recorded are shown on the table. Find the mean for Mai's data. Show your reasoning. Okay. The mean for her data. Now, we got a visual of what mean means here. It's a fair share. It's the idea that we want to kind of balance out what we've got here. But when we're given that in a numeric form instead of a visual form like a picture here, we're going to apply our thinking and use that more like that algorithm way. So, hey diddle diddle, the median's the middle. You add then divide for the mean. Okay, we're finding the mean. We're going to add then divide for the mean. So we're going to add up all these scores. So I've got 9 and 8 would be 17, plus 6 more would bring me to 23, plus 9 more. My pen stopped working. So I was at 17, then I added this, and I'd be at 23, plus 9 more brings me to 32, plus 10 would be 42, plus 7 would be 49, plus 6 would be 55, plus 12 would be 67, plus 9 more would bring us to 76, plus 8 would bring us to 84, right? 6 and 8 is 14, yeah, okay, sorry. Plus 10 more, 94, plus 8 more is going to bring us to 102. So there are, when we add up the data, so 9 plus 8 plus 6 plus 9 plus 10 plus 7 plus blah, 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 gives us 102 altogether. Now, we add then divide for the mean. This one, we're not working with cats and crates. We're working with minutes on the bus. So total minutes on bus. And we're going to split that up amongst the number of school days that she rode on that bus. So we had 12 school days, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many data points we had there. So that's what we're going to split this up amongst. So 12 school days. And when we do this, and it's very common with the mean or the average here, that you're going to get a partial answer. It's not always going to be a perfect, pretty whole number. So if I think of my 12 skip counts, I'm at 12, 24, 36, 48, 60, 72, 84, I'm getting close, 96, and another 12 would bring us to 108. So that'd be over my 102. So it's looking like I'm going to 8 and 8 minutes, 8 and some. So 8 times 12 would be 96, 97, 98, 99, 100, 101, 102. So that leaves me 6 remaining. And we were dividing by 12. So 8 and 6/12. In other words, 8 and a half. 6/12 is the same thing as 1/2. That's just a much more common way to see that. Or if you're a decimal fan, you could always call this 8.5 minutes as well. That'd be another way to show that same exact concept. So in this situation, what does the mean tell us about Maya's trip to school? Well, it tells us on average how long it takes to get there. Some days, I don't know if maybe she has to wait for, maybe there's a train track that she gets stopped by or traffic, and perhaps other days the traffic's moving really smoothly and she gets there really quick. But on average, it takes her about 8.5 minutes. So we know her typical travel time to school and how she can kind of plan out her mornings. All right, I think that'll get you a good start. There's always the lesson summary page to reference if you have any questions, concerns. There's always those terms in bold that'll help you out. Either go do some practice problems or Khan or Freckle and let me know if you've got any questions or concerns. Till next time, bye guys.